This video is for the project submission of the MCG 4136 Mechatronics project. This project is presented to you by Al-Barr, Kenneth, and Mihir. Project 1 is to create an Arduino circuit that allows us to spin a shaft in a single direction without any speed or alternative motor control. The following circuit diagram is provided to us in order to create the circuit. The main components of the circuit include a momentary push button, a resistor acting as a pull-down resistor, a MOSFET which acts as a digital switch, as well as a diode which helps bring the connection together. The push button acts as a digital input for the system, which will allow the Arduino to then communicate with the MOSFET, which will act as a digital on-off switch, which will then control how the current is going to be sent either to the motor or not to the motor, and completing the circuit with the 9-volt battery power source. The following images illustrate how we have recreated the Arduino circuit using the provided components and our breadboard. Note that a blue piece of paper is added onto the motor in order to indicate that the motor is actually rotating. Additionally, we have used a helping hand in order to hold the motor in place and to allow it to not have any interference while it's going. The conclusions we can draw from Project 1 is that a transistor, when attached to an Arduino, can act as a digital switch. This is good because it turns our momentary switch into something that can permanently turn on or off a circuit. Additionally, transistors have 3 pins, and for bipolar junction transistors, or BJTs, like the one used in our example, the pins are named the base, collector, and the emitter. A small amount of current on the base pin closes the circuit between the collector and the emitter pins. BJTs come in 2 types, and the one we are going to focus on is using the NPN type transistor, which means that the collector will connect to the motor and the emitter will connect to ground. The limitations of this circuit design is that we can only control if a motor is going to turn on or off. We have no ability to control the PWM waves, in which case we cannot control the speed, nor can we change the direction in which the current is traveling in. The Project 2 with the Arduino focuses on using an Arduino along with an H-bridge to have more advanced motor control. This means it will allow us to change flow of the current as well as the speed of the motor. The following circuit diagram was provided and followed in order to create the circuit. It uses 2 momentary push buttons, a potentiometer, an H-bridge, and 2 pull-down resistors in order to control the battery and motor. The circuit diagram also further breaks down that we are using the 2 momentary push buttons as a digital output, as well as connecting a op-amp, and the op-amp we will be using is an L293D op-amp, which is also a H-bridge. The use of this H-bridge will allow us to control PWM waves, in which case we can control the speed as well as the direction or flow of the current. For controlling the rotation direction, we just need to inverse the direction of the current flow through the motor, and the most common way of doing this is by using the H-bridge that we mentioned before. An H-bridge contains 4 switching elements, transistors or MOSFETs, with the motor at the center forming an H-like configuration. By activating 2 particular switches at the same time, we can change the direction on the current flow and thus change the rotation direction of the motor. The following images demonstrate how we have recreated the circuit using our provided equipment and breadboard, and finally it will demonstrate how we can actually control all of the circuits in the following video. Issues that came across when we were creating the circuit, however, were some of the wiring was somewhat faulty, as we were required to add additional force in order to ensure that the circuit was properly grounded throughout. And off.
Okay.
Wait, you do that again?
Oh, okay. Do it again.
Okay, so decrease speed, increase the speed, decrease the speed, direction,
Nice.
different change of direction, max up the power again, and then off.
Perfect.
The conclusions that we can draw is that the H-bridge, using its 4 switching elements, allows us to change the way the current flows and change the direction in which the motor is going to rotate at. Another thing that we've learned in this project too is that we can change the PWM wave to then change the speed of our motor, as well as the fact that this project 2 builds on project 1 in terms of project 1 using a MOSFET and project 2 using an H-bridge, which is a combination of MOSFETs. Thank you for watching our presentation.